So the big picture for this lesson is trig identities, and here are the identities that you're going to be working with. First of all, reciprocal identities. Cosecant of theta is 1 divided by sine theta. Secant of theta is 1 divided by cosine theta, and cotangent theta is 1 divided by tangent theta. These are all reciprocals. Tangent and cotangent identities. Tangent of theta is sine of theta divided by cosine theta. Cotangent theta is cosine theta divided by sine of theta. And also remember that tangent and cotangent functions are reciprocals of each other, which is why sine of theta is in the numerator for the first one, and cosine of theta is in the numerator for the second one. Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. And then there are two others you can see here involving tangent squared and secant squared, cotangent squared, cosecant squared. Cofunction identities. Sine of pi over 2 minus theta equals cosine of theta. Cosine of pi over 2 minus theta equals sine theta. Tangent of pi over 2 minus theta equals cotangent theta. And you can see the negative angle identities. The sine of negative theta is negative sine of theta, and so on for the others. So why are all these useful? What you're going to be doing is you're going to be using these in simplifying complex trig identities. An identity is something that is always true. It's not really like an equation. An equation is only true some of the time for certain values of x, sometimes only one value of x. An identity is true all the time. And you can't use equation steps when you're solving trig identities. All you can do is simplify one side and the other side. An identity is not an equation, so you can't really treat it the same way, at least not until it has been verified. And there are plenty of videos and examples in the lesson that show you how to simplify identities so you can verify them using the proper steps. And so that's what you're going to be doing in this lesson. That's the big picture.